G'day everyone, in this video here we're going to be looking at constructing a stem and leaf plot from a set of data. So we do this so we can organize our data and we can make better judgments or compare it to other sets of data. Okay, so this is the point of organizing it in a stem and leaf plot. So you start off by organizing a table to the right there with your stem up the top, so up here, and then your leaf. Okay, and then making enough space so there's enough spots for your stem to go down. So what I've done here, I've got the numbers 0 to 6. I've made it a bit longer than it needed to, but anyway, so we've got 0 to 6 because if we see here our stem, our first numbers over here, they start from 0, so we've got 0.2 there, and then they go all the way to 6, and I just need to find it. Oh, it's right next to it, 6.4 to there. So that's our range of our data. So this will be our highest and our lowest number. And our leaf, that just there is the point. So with this one, it's 0.2, which is our smallest one. So we write a 2 here. Okay? So that shows 0.2. And whenever you write it off, cross it off your data set. So I've crossed that one off there. Okay, so our next one is 0.3. That's down here, so I'm going to cross that off. And I'm going to go through a few of these. We've got 2 at 1.4. Just need to cross these off. There and there. So it's always important to have this and to always check because it is very easy to miss one. So I'm just going to go through and write. We've got 2.0, 2.3 and 2.5. 2.0 is there, 2.3, 2.5, cross it off so we don't make sure we don't make a mistake. We've got 3.1, 3.4, 5, 8, and 9. So it is really important to make sure that your data lines up. So you can see here I'm using each square as a different value. So it is really important to make sure that you do this, okay? Or else then you can't make judgments from your data. So make sure it does all line up. So we now have 4.3, 4, 7 and 8. Okay, 4.3, 4.7, 4.8 and 4.4, and then you can see here I've just got 5.1, 5.6, 5.7 and then 6.4 left. Okay, so I've crossed them all out after I've done it. So now we haven't missed any bits of data, so it's all there, it's accurate. That's probably the most common mistake with making stem and leaf plots. So this is our ordered stem and leaf plot, and we need to have a key down the bottom. So in this key down the bottom, I just need to write what it means. So I'm just going to say for example, 3, and then a line to represent in between the stem and the leaf, 4. This means 3.4. Because different sets of data, this could mean 34, it could mean 3,400, it might mean many different things. So it's just always good to have a key so the reader understands what that number actually is. So now with this, we need to try and find our median. So with this, all we need to do is find our middle number. So for this, we just need to count how many we have. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that means there's actually going to be an even number, which means there's going to be 2 middle numbers. So these 2 middle numbers are going to be right here, okay? So this is the 10th and 11th number, okay? So there's 20 numbers in total. So it's the 10th and 11th that are the middle ones. And we need to take the average of these two. So to work out the average or the mean, so the median is equal to, we need to work out the mean of these two numbers, sorry. So we need to do 3.5 plus 3.8 divided by 2. Okay? So this here then gives us the value of 3.65. Okay? So that's how we work out the median. So just be aware whenever you have an even amount of numbers in total that it's going to be two numbers and you need to take the average of those two numbers, just like I did there, or the mean of those two numbers. So part C here, we need to find the mode. So which number was the most or came up the most? And I'm going to do this in yellow. So we can see here we've got two 1.4s, okay? And there's no other number that appears twice. So this means that the mode is 1.4, okay? Then finally, this idea of describe the data as symmetrical or skewed. So this means, and this is why it's good to order as a stem and leaf, this means if most of the data is down one end or the other, that means it's skewed. So if it's approximately sort of an even amount on one side to the other from the middle, this means it's symmetrical. So I'm just going to hopefully just erase what I've done here, there. Yep. So we've got our middle line right here. Okay. So we look above and below this. Okay. We've got 3, 4, 5, 6. We've got 7 up here. We've got 4, 5, 6, 7, 8. So we've got 8 here. So we can tell that our data here is approximately symmetrical. It doesn't need to be perfect. If you really want to be even more accurate, you can see this is the middle of your data, and then just saying you've got, so you've got 7 here, 8 here, and they're approximately the same distance apart. Okay, so it is important just to have a bit of a look at that. So they're all about the same distance apart. So this one, it looks symmetrical. So it is a bit of a guessing game. It isn't perfection. So this one is approximately symmetrical. Okay, if it wasn't symmetrical, you would see most of your data down one end. So you might see something, and I'll just do it in green. It would look something like this. You might have, just following these lines, it might look something like this. Okay, so this one would be skewed if you were just following the line, the highlighter lines of what data it was covering. This one would be skewed, okay, because most of the data is down this end, okay. But our last one, our actual example there, most of our data was in the middle, so it was symmetrical. So hopefully this gives you an understanding of the difference between skewed and symmetrical, and gives you an understanding of how to construct stem and leaf plots. And good luck.